when you draw your first derivative of this black function, what we get here is the red function. The key points when you're trying to draw the graph of the derivative is to look where the slopes of your graph are 0. You see at these 3 points your slope is 0. So you see right here I put my values of 0 because my slope values are 0. And if I'm trying to draw the derivative, which are the slope values, those would be 0. So they're key points in helping me draw my derivative. Then next I look at each interval and I say that's going downhill, so I have negative values. For this interval it's going uphill, so I have positive values. And then for this I'm going downhill, so it's negative values. And then uphill, so it's positive values. And the key is you don't really have to worry about how high these relative maxes and mins go because you're just sketching it. The key is just I have to get from this dot to this dot and stay above the x-axis. So we don't know exactly perfectly how high it actually goes. Now it is kind of important to know that your relative max would be somewhere between these, kind of more in the middle of them. Here your relative max will probably be right in the middle of the two dots. That's kind of important because when you're doing your second derivative, which is in the green, you look at the max and min of the first derivative. Because the max and min of the first derivative are the points of inflections. Okay, do you see how the max here, the min here, sorry, is the point of inflection of my black graph? Do you see how the max here is where the point of inflection is of my black graph? Do you see where the max is here? I have a 0 for my second derivative. Remember when you're trying to find points of inflections, don't you set your second derivative equal to 0? So see how my second derivative here is equal to 0. See right here? My point of inflection here is where my second derivative equals 0. So your first derivative will help you find these two dots, which help you graph it. So when you do your second derivative, look at the max and mins of the first derivative, set your zeros, and then look at your basic red graph like it was your original function, for instance. All right, if I want to know this, I can look at my red graph and see, okay, the red graph is increasing, so I have positive values. My red graph is decreasing, so I have negative values. My red graph is increasing, so I have positive values. All right, so that's one way. You could also just look at the concavity. See from this dot to this dot, see how it's concave down? So you have negative second derivatives. Got that? Do you see right here, from here to here, my concavity is up, so I have positive concavity, positive second derivatives. So you can look at it in multiple ways. But the key is finding these dots on the x-intercepts. Your green graph, so your red graph here, for your first derivative, you want to look at the maxes and mins. Okay, for your second derivative, you want to look at the maxes and mins of your red graph, or your first derivative. All right, and you also always want to look back to your black original graph, whatever it was, to make sure that it makes sense in the end. So it's all like once you're done with these, and look back through the whole thing and make sure it all kind of fits for each graph.